Okay, 4.9 cross product. So we had a determinant last time, right? So 2 by 2. Determinant. So we knew that the first one is row, right? And second one is column. So 2 by 2, then let me denote it this way. So a sub 1, a sub 2, b sub 1, b sub 2. Then we calculate it this way. Diagonally product a sub 1, b sub 2, subtract a sub 2, b sub 1, right? Okay, how about 3 by 3 determinant? Ooh, where is my, okay. So 3 by 3 determinant. So this one we can express a sub 1, a sub 2, a sub 3, and b sub 1, b sub 2, b sub 3, c sub 1, c sub 2, c sub 3. Okay, so we went over this one last time, right? So like a cofactor expansion, we make a positive for the first one, negative, positive, negative, positive, negative, positive, negative, positive, right? So what are you doing for this one? So we take out the a sub 1. That's a positive, right? Then we cross out. So we will get b sub 2, b sub 3, c sub 2, c sub 3, right? And secondly, minus and a sub 2. So we take out the first row, second column, then we cross out that. So we are using b sub 1, b sub 3, c sub 1, c sub 3, right? So if I make a mistake, please let me know. And a sub 3 we take out, then that's positive. Then there will be cross out first row and third column. So b sub 1, b sub 2, c sub 1, c sub 2, right? Then 2 by 2, we can easily calculate. So there will be a sub 1 and b sub 2, c sub 3 minus b sub 3, c sub 2 minus a sub 2. Then b sub 1, c sub 3 minus b sub 3, c sub 1 plus a sub 3 and b sub 1, c sub 2. Oops, no space. Hold on. And b sub 1, I don't know where we are doing. B sub 1, C sub 2 minus B sub 2, C sub 1, right? Okay. All right. So we had the example, this one, last, probably before dot product, right? Okay. What is the cross product then? Cross product. Cross product is same as 3 by 3 determinant, but a little bit different expression. So cross product. That's the title, right? Cross product. Okay, so let me say the thing. 3 by 3 determinant. Okay, so we have U with the vector notation, vector, right? So components is U sub 1, U sub 2, U sub 3. And then we have V equal to V sub 1, V sub 2, V sub 3. And then we have U cross product with V, right? So this is cross product symbol. And we read cross product of U and V. V. So read cross product of U and V. Okay, then look. So we had earlier A sub 1, A sub 2, A sub 3, right? So instead of that, we do I ijk, right? ijk. And then we talk about ijk is unit vector last time, right? So unit vector, let's denote like a hat. Okay. Then we have u sub 1, u sub 2, u sub 3, and v sub 1, v sub 2, v sub 3. Okay. So I introduced you before ijk come from this, right? So I, 3 dimension, and oops, I'm crazy. Forgive me. Let me denote. Better. Okay. So I saw 1, 0, 0, right? And J with the head. And this is 0, 1, 0. And this is K. And this is 0, 0, 1. Okay. Now, how do we calculate the cross product of U and V? So let's take out the I here. And then we knew plus, minus, plus. So minus and J and plus K, right? Okay. So same as earlier, 3 by 3 determinant. So we crossed out like that. So we are using this one, right? So let's copy and paste. Copy. Very good. Now J. So cross out first and second column. So U sub 1 and U sub 3 like this. And K. So we're using like that. So let me just make a copy and paste. Okay, very good, right? Okay, let's calculate. Okay, so we calculate this way, right? So U2, V3 minus U3, V2, I minus U1, V3 minus U3, V1, J, and U sub 1, V2, right? Minus U sub 2, V sub 1, right? Okay. All right. So ijk is the unit vector. So unit vector means magnitude equal to 1 and same direction of the vector, right? So means magnitude and same direction of the vector. So I introduced earlier ijk, right? So one more time. So we have ijk, right? So ijk unit vector there, right? Okay, so but then in 3 dimension, this is x axis, and then this is a negative x axis. And this is the y-axis. And this is the negative y-axis. And this is a z-axis. Third one. And this is negative z-axis, right? So 1, 0, 0. Let's make this is a vector I, right? And j 1, 0, 1, 0. So this is j. And this is 0, 0, 1, k. Yeah. So we denote it like that. All right. Example. We have a p negative 1, 2, 5. And q, which is 4, 0, negative 3. Now we want to find the cross product of p and q. Okay, so we have p cross q and I, j, k. So we knew that just the vector notation, right? Once again, and this is unit vector notation. So little slightly different, right? So this one and this one. Okay. So we have negative 1, 2, 5, and 4, 0, negative 3. Okay, so ijk minus j k. Okay, I, so we have a 2, 5 overestimate. So that is 2, 5, 0, negative 3, right? J, so negative 1, 5, 4, negative 3. K, so negative 1, 2, 4, 0. Yes? Okay. So please calculate this one, right? So negative 6 and positive and 0, 8, right? Okay. So negative 6. What is the second one? Negative and negative is positive. Negative 8k. Can you confirm? Okay. Can you please try? Let me write down. This is A. How about Q cross the product of Q and P? Q for 0, negative 3, P, negative 1, 2, 5. Okay, I minus J plus K, right? Okay, I 0, negative 3, 2, 5. J 4, negative 3, negative 1, 5. K 4, 0, negative 1, 2. So we have 0 minus plus 6 and minus 20 minus plus 3 plus a minus 0, right? Okay, can you please calculate? Hold on 1 second. I made a mistake, right? So this is negative. Because negative negative is positive, right? Okay, so there will be 6i minus 17j plus 8k, right? Okay, now, what do you think about this one? Can you take a look? So this is P cross product of P and Q. This is cross product of Q and P. What can we summarize? So write down in the chat, or you can talk, or private DM, direct message. Yes? What do you think about this one? How do we conclude? Hmm. Nothing? Number is the same, right? Hmm. Oh, can you talk about the sign then? Sign is what? Hello. Hello. Oops. Why this is moving? No one can see this one? How do we determine? Okay, so we can say that. Very good. Yeah, thank you. In the chat. Yes, it's the opposite, right? Sign is opposite. So we can conclude. So let me see. PQ. Cross product of P and Q. Let's just using the number. So it's -6, +17, -8. And we have Q cross P. Then we have 6, -17, 8, right? The sign is opposite, right? So we can say that cross product of P and Q is the same as negative, oh, negative of cross product of Q and P, right? Makes sense, right? Okay, now I'm gonna show you this one. If we have P, vector P, and -1 and 2, 5. Oh, this is the same one, right? And then we have a Q, which is 4, 0, -3. Okay, now, so let me draw. This is Z. This is X. This is Y. Okay, so as I told you earlier, so this is a positive x-axis. And this one is a negative x-axis. And this is negative. Let me just draw. So this is a negative. Erase. Oh, like that. So okay, and this is negative y-axis. Is it straight? Okay, then erase the line. Okay, then z. Erase the line. Okay, now I want to plot the point -1 to 5. That is x, y, z, right? So -1 start to -1. So this is the origin. So 0, 0, 0, right? So -1, we're going to -1 here. And then 2. So 1, 2, because y is the positive 2, right? 2 unit. Okay, from the 2 unit, we're going up 5 units, right? So I'm not going there 5 units. From here, 2, and then I just measure 5 unit up from straight, right? So 1, 2, 3, 4, 5. And then parallel with the z-axis. Not sure, but it's about here, right? Yeah. So -1 to 5. Once again, -1. We start at -1. This is -1, and then go 2 units to the right because y is positive. 1, 2. Then we make up 5 units. 1, 2, 3, 4, 5. Oh, very good, right? Okay, now this is a P. Okay, how about 4, 0, -3, right? So 4, 0, -3. So we have +4. So 1, 2, 3, 4, and then 0, we stay there because y is 0, right? And then -3 units for the z. So we're going down 3 units down. So we're not going there 3 units. From here, so this is a 4. 1, 2, 3, 4, and then 3 units. 1, 2, 3. So there will be the cube. All right. So let me hurry up to grab the pen. Probably here. Let me double check. So 4, 1, 2, 3, 4, and 1 from here. 1, 2, 3. Yes, very good. Okay. So parallel to the z-axis. So that will be Q. Okay, let's connect the point. Okay, now we have, let me bring this one here. Cross product of P and Q and cross product of Q and P. Oh, the number is too big. Okay, so the cross product of P and Q, let me just using pen. So let us do that. Like, okay, so -6, So 1, 2, 3, oh, different color. 1, 2, 3, 4, 5, 6, and then positive 17. So, oh wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So not accurate, but approximate here. And not perpendicular, parallel with Z. So that would be P cross Q, right? Okay, now I want to make a Q cross P product, cross product of Q and P. So which is positive 6. So 1, 2, 3, 4, 5, 6, and negative 17. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then positive 8, right? So parallel with the y-axis, right? A little bit twist. And then positive 8. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So this is all. This will be Q cross product of P, right? So let's connect. Okay, so a little bit off the origin, right? Let's just pretend. Okay, so what we are doing this, the P cross product of P and Q is orthogonal to P and Q, all right? So let me write down. Cross product of P and Q is orthogonal. So what was the orthogonal? We introduced this vocabulary last time, right? What was it? Perpendicular. Thank you very much in the chat. Excellent. Orthogonal to P and Q. So perpendicular means, I mean, sorry, orthogonal means perpendicular. Okay, now, then how can you say about cross product of Q and P? Same, right? Orthogonal. Orthogonal to P and Q as well. Okay, let's check it out. Check it out. Okay, so can you see that? Cross product of P and Q is orthogonal to P and Q, yeah? Make sense? And then can you see the cross product of QP is also orthogonal to P and Q, right? So like this. Okay. We have a theta. Properties. Properties of cross product. Okay, so let U, V, W are vectors. And C, B, scalar. The first one, U cross V equal to What was that? What was this one? We can make a commutative with negative sign, right? U, right? Earlier, like P cross Q equal to negative Q cross P, right? Okay, now we have second one, U cross V plus W. Then we can distribute. So that will be U cross V plus U cross W. And okay, so we have a properties of a cross product, right? So we did that, this one, and then this, that. Okay, so we have one more. We have a dot product. And then U cross of V is U cross V with a dot product. Okay, so I will show you this one later with the numbers, all right? Okay, so we have a theta. So magnitude of cross product. So dot product related with the cosine, if we talk about the angle, right? Then cross product related with the sine. So let U, V vectors, and theta is angle. So we denote cross product and magnitude. So we using the double line, right? Then magnitude of U, magnitude of V, and we have a sine theta. Okay, let's using this one. Find the magnitude of cross product of U equal to 0 for 0, V equal to 0, 0, -3. Okay, now we want to find the magnitude. We want to find the magnitude of cross product, right? Then there will be magnitude of U cross V, which is that, right? So I am using this one, right? This formula. Copy. Okay, now we knew the magnitude of U, that is square root of 0 square plus 4 square plus 0 square. And then magnitude of V, which is 0 square plus 0 square plus -3 square, right? How about sine? How can you indicate the sine, the degree? Can anyone has guessing? What kind of angle we have to use? Thank you. In the chat. Yeah, Okay, so let me give you a hint. We are using 90 degree. Why? Why we are using 90 degree? Ah, very good. Because perpendicular, right? So very good. Thank you for participation. Okay, so it's a 90 degree, right? So can you please calculate what you get? 4 square, which is 16, 9. And then sine 90 degree, what do you get? Sine 90 degree. Is it 0 or 1? Yes. Okay, so we have 4, 3, then we get 12. Yes? Okay. Any question? All right. So we have a vector A, which is 5, 2, -1, and vector B, 0, -1, 4. Find unit vector orthogonal to A and B. Okay, so does anyone remember the formula of the unit vector? So we have U. So since unit vector, we are using unit vector like a hat. Oh, thank you in the chat. So unit vector, the formula, and that will be 1 over magnitude of vector U. And since we're following their same direction of the vector, we are using vector U. All right? Okay, very good. Thank you. All right. Now, we knew that what is orthogonal, right? So orthogonal to A and B. Then we just learned that magnitude of, no, not, we don't need the magnitude. A, cross product of A and B is orthogonal to A and B, right? So cross product of A and B is orthogonal to vector A and vector B. Okay, now, so look, we want to just replace U here, like A cross B, and then U here, also A cross B, all right? So, you guys understand? Vector, unit vector, very good. And then now we express A cross B with a magnitude, and then A cross B, okay? That will be unit vector orthogonal to A and B. All right, so this is the one. So basically we are using the unit vector formula. We just change it. U as a cross product of A and B. Okay? Okay, let's do that. Can you please try A cross B? Thank you. Okay, so let us do that. So that will be I minus J and plus K, right? Okay, I 2, -1, -1, 4, J 5, -1, 0, 4, K 5, 2, 0, -1. What's the sounds? Okay. All right, now, so A minus 1, I minus 20 minus J, 0, J plus -5 minus 0, K, right? So what do you get? 7I minus 20J minus 5K, right? Very good. Okay, now I want to use the formula, which is we just created. Copy. Okay, so there will be 1 over we just found cross product of A and B, right? So that will be 7I minus 20J minus 5K. But we have a magnitude. So we are using the length. That means we make a square root of them. And we are using 7 squared plus -20 squared plus -5 squared, right? So can you please calculate? And then that will be 7I minus 20J minus 5K. So what do you get this one? Hmm? What do you have? Thank you, Dream Messages. Okay, so 474. Really appreciate that. So this is 1 over square root of 474. So there will be square root of 474. 74. Okay, thank you very much. Okay, so dot product, if we talk about the angle, it's cosine related, right? And then dot product is good for we using projection, right? But then cross product, It's good for, we are using the finding area of triangle or parallelogram or parallelogram. I said parallelogram, right? So we have a 3 dimension. What's the name? I totally forgot. Parallel pipe. Yeah, 3 dimension. 3 dimension of a parallelogram we called parallel pipe. Yeah. So let me write down later. Okay. So let's do it. Okay. So area. Excuse me. Parallelogram. Okay. So parallelogram. So this side, same, right? And so bad with it. Haha, looks a rectangle. In different messages. Okay, hold on. Uh, we know that parallelograms, so they are same size here and there, right? And they are also same size here and there, right? And then parallel each other, this line, right? And parallel with this line, right? Okay, now we want to make here perpendicular with the line. Okay, so if we indicate that this is a vector v, we indicate the angle theta, then this is a vector u. So area of a parallelogram, so that is base times the height, right? Okay, then we express the vertical line, the green one, so there will be, we talk about the length, right? So there will be vector v sine theta. So we had this on the last time, right? So if we indicate this one, then we have vector v, then we are using length of vector v and then cosine theta, right? Because this is the x. And then y, then we are using the length of vector v and sine theta, right? So this is y vertical line. So we are using length of vector v sine theta, right? Okay. So base, which is u, right? But we talk about the length. So base will be length of u, and then height, which is green. So we are using magnitude of vector v and sine theta. Make sense? Okay. Then what is this? Very good. Yes. This is cross product, right? With a magnitude, right? So magnitude of u cross over v that come from earlier, right? So, okay. Let me denote this one, note. Oops. So we have B, and then we have B sine theta, and this is B cosine theta. Yeah. Okay, let's do example. We have time. We have a point 1, 0, 0. We have a point 0, 1, 0. We have a point 0, 0, 1. B vertices of a triangle. Find its area. Okay, so this is a triangle. We had earlier parallelogram, right? Okay, so we make a divide by 2, then that's the area of a triangle, right? Yeah. So normally formula of a triangle come from area of parallelogram, right? Okay. So note, find the area of parallelogram in cross B, then 1/2 cross B, area of triangle. Okay, so let's do this one. Find the vector PQ. Okay, so we can find the vectors. So 0 minus 1, 1 minus 0, 0 minus 0, right? Then we get -1, 0, 1. And we have, I'm sorry, this is a PQ. Did I make that? Yeah, so sorry about that. PQ. So -1, 1, 0, right? -1, 1, 0. How about PR? So we have 0 minus 1, 0 minus 0, 1 minus 0. So we have -1, 0, 1, right? Okay, so we make a cross product of those vectors, PR and PQ. So IJK. So we have -1, 0, 1, -1, 1, 0. I minus J plus K. So I 0, 1, 1, 0, and then J -1, 1, -1, 0, K -1, 0, -1, 1. So we get 0 minus 1, I minus 0 minus plus 1, J, and plus -1 minus 0, K. So we get -I minus J minus K. So we get the magnitude of PR cross product of PQ. Then we have -1 square plus -1 square plus -1 square, which is Square root of 3. Now, we need to find area of a triangle. It's a square root of 3 over 2, right? I just explained to you, right? Can you please calculate approximately? While I'm writing this one, please calculate. U equal to 0.866? No, okay. Someone confirm? V equal to 2, negative 1, 0. W equal to negative 3, 0. Okay, so confirm? Okay, so I was erasing the example because we want to do triple scalar product first. So this number is confirmed. Triple scalar product of vectors U, V, W is, so U dot product and then cross product V, W equal to this one. We can write down this format, which is U sub 1, U sub 2, U sub 3, and V sub 1, V sub 2, V sub 3, W sub 1, W sub 2, W sub 3. Okay, so this one, same as IJK, we can write down this way. I, right? U sub 1 minus J for U sub 2 plus K for we say U sub 3, right? Okay, so we do example. Yeah, I should write down, huh? Should write down. U sub 1, so V sub 2, V sub 3, W sub 2, W sub 3. U sub 2, V sub 1, V sub 3, W sub 1, W sub 3. And then U sub 3, V sub 1, V sub 2, W sub 1, W sub 2. Yeah? Okay. Now, the example I erased earlier. So we are going to use that. So U equal to 1, 3, 5. V equal to 2, negative 1, 0. W equal to negative 3, 0, negative 1. Okay. So how do we calculate dot product of U and cross product of V and W, right? Okay, we are using the formula, the form like here, right? So there will be 1, 3, 5, 2, negative 1, 0, negative 3, 0, negative 1. Okay. So there will be I, right? So 1 minus J, 3, like that, and plus K and 5, like this, right? Okay, so there will be -1, 0, 0, -1, and 3, 2, 0, -3, -1, 5, 2, -1, 3, -3 is 0, right? Please correct me if I make a mistake. So this is a positive 1, 0. 1 doesn't do anything, so no need to write. And -2 minus 0, 3, and plus 0 minus 3, right? Okay, so there will be 1 minus and distribute -6 and plus -8. Or do you get this one? Hold on 1 second. I made a mistake again. Yeah. So this is not -15, right? So what do you get then? Sorry. Yeah, it's -8, right? Thank you. Yes. Okay. Very good. Yes. Okay. Now, this is -8. Let's check that. Let's check. Because I want to show this one. The earlier properties. So earlier properties say that this one. And then I said that I'm going to show you with a number later. So this is the time. You copy. Okay, so let's do this one. Okay, so all right, so whether we get the same number or not, oh, okay, so let us do this one. Check that. Cross product of U and V and dot product of W, right? Okay, now there will be, I need a number. Okay, 2, -1, 0, -3, 0, -1. Oh, no, no, no. U cross V. Okay, sorry about that. U cross. So I am using exactly same. And then what's the difference between there? Let me explain to you. So I am using same. Okay, then V is here, right? This is a, I'm sorry, W. So this is a W. Okay, then W acts like IJK, like what you did, all right? Okay, now, then we have to count the signs. So we have plus, minus, plus, and minus, plus, minus, plus, minus, plus, okay? All right, now let's do that. Positive and negative 3, right? And 0. So minus 0, everything's 0. And then positive, well, there is negative. So positive, negative 1, right? You guys okay with this? Very good. Thank you. In the chat. Okay, now negative 3. So I am using 3, 5, negative 1, 0. And negative 1. So I am using that. So 1, 3, 2, negative 1. Yes? Okay. That will be, so 0 minus positive 5 and negative 3 minus 0 plus negative 1 minus 6 and negative 1, right? Can you please calculate? What again? Oh, can you please stay here 5 more minutes? I have one theta, volume of parallel pipe. It's negative 8, right? So we can conclude. So okay, can tutor can ask her in the chat, please? I want to finish this one, or please stay after class. I can answer your question. Okay. Okay, thank you. So let us do the last one. This is the theorem, volume of parallel pipe. So 2-dimension, we have a parallelogram, right? So it's a 3-dimension of parallelogram. So we called parallel pipe, all right? Okay. So we have the volume of a parallel pipe with adjacent edges given by the vectors u, v, and w is the absolute value of the name triple scalar product, right? So triple scalar product. We just did that. Okay, so we are using the first letter volume, yeah, V equal to U dot with V cross with a W, right? Okay, so this is the last example today. Thank you for staying here. 5 more minutes. Okay, find the volume. Negative 2, 1. V equal to 4, 3, 2. W equal to 0, negative 5, negative 2. Find the volume of parallel pipe with adjacent side edges U, V, W. Okay, So V equal to, we are using the formula. Okay, so we knew that will be -1, -2, 1, and 4, 3, 2, 0, -5, 2. Okay, since we don't have time, I'm gonna just do it. But at home, you try by yourself. So we want to make an absolute value because it's a volume. We don't want negative. So whole thing is absolute value. And then the first one, -1. So -1 minus -2 plus +1, right? Okay, so -1, so we have 3, 2, -5, 2. -2, we have 4, 2, 0, 2. And 1, 4, 3, 0, -5, right? I hope I don't make a mistake. Okay, so absolute value whole thing. So we have 6 minus plus 10 with a negative, right? And then 8 times -2 plus -20, and 1 doesn't do anything. Can you please calculate? Then we are done, right? Did I make a mistake? Okay, no. Okay. I made a mistake, yeah? Rushing. So negative. Also 4 to 0, -2. That is good. So that will be -6 and then -8. Okay, sorry about that in the chat, yeah? So we get +40. Can you double check? Yeah. So we have a -40, we have an absolute value, and then positive, yeah? Thank you very much. Yeah, thank you so much. Thank you for coming in on time and your participation.